Hi, welcome. In this video I'm going to be showing you how to use WipFrag new error detection approach to solve your fusion and fission problem in image analysis. First of all, I would like to introduce you to both classic error detection parameter tool and the deep learning. I'm going to be using two images to perform some comparison in this video. The first picture is going to be showing here is having two scale material. As you can see, the advantage of the two scale material is to account for any form of slope in this image, which can actually affect the output of the software. So the classic error detection result, as you can see here, is showing some effects of fusion and fission in the analysis. You want to ask what is fission, what is fusion. I'm going to explain this in detail in a couple of minutes. So you can see the picture is expressing the performance of classic error detection directly without any editing, then the deep learning without editing. This is how the result looks like. There's a lot of fusion, there's a lot of fission in the classic error detection without editing. Then the deep learning gives a very classified fragment that gives good results. You want to see how the result looks like? Here. The result is actually showing that classic error detection is underestimating the DAT. We have the 64.08 millimeter for the DAT particle size, but the deep learning is showing more results to be 93.29 millimeter. Then here is another image. This is a more clearer image that is actually captured with good quality, and we have the classic error detection giving more good results. Then the deep learning also is showing at the other side. Then this is the result. We still have some fusion, that is material coming together as one being identified by the software. Then you have the deep learning showing forth a good result. Then here is the result. As you can see, as the quality of the image is improved, the classic error detection performance also improved. Then you can see the D50 of the classic error detection analysis is showing 68.86, while the deep learning is showing 68.14, very close as compared to the first image. Then these are the common problem with classic edge detection: fusion. As its name suggests, it consists a kind of scenario in which large fragments is actually broken into two or more smaller fragments. As you can see in the image, that is a lot of fragments and they're actually being broken into smaller ones. Then we have the fusion. The phenomenon is reversed as compared to fission. In fission, you have many materials being identified from a single boulder. Then in fusion, you have a lot of materials being classified to be a boulder. Then what can be the cause of this problem? The first cause is the quality of your image. When you supply a poor image quality to the software, then you get such issue as this. Then another issue is the poor selection of edge detection parameters. Then how can you solve the problem? The first thing is to get a very good quality image. You can browse through the software and you find some materials available for you at the library store on how to take image sample right from the mine. Then other things you can do is using the WipFrag editing tools to improve the fragment identification. The first tool that is available that you can use is the free draw tool. It allows you to trace the edge of the fragments directly. Then you have the lasso delete, you have the disintegration tool, then you have the lasso delete plus outline tools, and many more. To avoid all this editing and time down analysis period, you better still use the deep learning edge detection type and avoid fusion and fission. And this is where you can always find the deep learning, as you have the simple as the classic edge detection type, then you have the deep learning edge detection type. When you click it, then you generate your net within few minutes and you have a good analysis to play around with. Thank you.